Hello everyone and welcome back. In this lecture we'll continue our discussion on decision trees and random forests. So now that we have built our model, it's time for evaluation, and we'll use confusion matrix and classification report for evaluation. So let's start by importing them from scikit-learn's metrics. So from sklearn.metrics, let's import classification report and confusion matrix. Okay, now we can simply say print. We can simply print the confusion matrix and classification report. So confusion matrix, and then we'll pass our y-test and our prediction. So our prediction is our model.predict, and then we pass x-test. Let's run it. So this is our confusion matrix. We have 50 and 59, almost a total of 109 misclassified datasets. So those are the false negatives and false positives, 50 and 59. And let's print out the classification report and check out our result. Print classification report, and then we'll pass our y-test and our prediction. Run it. So overall we have a precision of 77%, recall of 75%, and F1 score of 76%. And if you look at the specific results for yes and no, you see that we have a better result for good loans yes. So our model has a better prediction when our good loan is yes. That's why you see a higher precision, recall, and F1 score for the value yes. As you can see here, 86%, 84%, and 85%. Whereas when good loans is equal to no, those values are very low, 22, 25, and 24%. Overall, this is the result of our model, almost 75-76% accuracy. And from the confusion matrix, we saw that these are the the false positives and false negatives. So 109 are misclassified as either false positive or false negative. What we'll do next is check out random forests. We'll import random forest classifier model from scikit-learn, and we'll build a random forest classifier model and use our training datasets to train our random forest classifier model, and we'll make predictions off of that and see how our model does by printing out the classification report and confusion matrix for our random forest classifier model. And once we do that, we'll compare it with the decision tree classification. Let's start by importing random forest classifier, and it's in scikit-learn's ensemble. Remember, decision trees are in scikit-trees 3, whereas random forest classifier is in scikit-learn's ensemble. So from sklearn.ensemble, import random forest classifier. Once we import it, let's instantiate our random forest classifier model, and we'll save it in a variable called random forest underscore model. You can save it anywhere you like. So random forest classifier, and our random forest classifier method takes an attribute known as n estimators, number of estimators, and I'll pass 150. Okay, as an exercise for you, you can try out different numbers and see the results of your random forest classifier model. Okay, for now I'll pass number of estimators to 150. Okay, and once we instantiate our model, we'll call the fit method to train our model with our training datasets. We have seen that before, so let's do that. We have our random forest model, and we'll call the fit method, and then we'll train them by using our training datasets xtrain and ytrain. And these are the default values: class, weight, none, criterion. These are all the various default values, except for, of course, number of estimators. We specified that to be 150. You can check out scikit-learn's documentation on random forest classifiers to find out more about any of these attributes or parameters. Now that we have trained our model, let's predict using the testing dataset. Okay, so we have our random forest model. We'll call the predict method on it and then pass our training dataset x test, and let's save this in a variable called random forest prediction. Next, let's evaluate our model by using the confusion matrix and classification reports. We have already imported them from metrics, right, in the previous lecture, so we don't need to import it again. So let's print out the classification report. So print classification report, and we'll pass our y-test and random forest prediction that we just calculated. Let's run this. So this is the classification report. We'll talk about it later on. Let me print the confusion matrix and start our discussion from that. We'll pass our y-test and random forest prediction. Oh, this should be confusion matrix, not confusion report. Okay. So for our confusion matrix, 62 plus 12, that's 74. 74 of them are misclassified as false positive and false negative. Using the decision tree model, we saw that 109 of them were misclassified, whereas using the random forest model, only 74 of them are misclassified as false positives or false negatives. And if we check out the classification report for our random forest model, we see that it has an average precision of 77%, recall of 83%, F1 score of 79%. Overall, we have a bit better result compared to our decision tree model, right? Our decision tree model had 77, 75, 76%. So our random forest did better on recall and F1 score compared to the decision tree classifier. And if you look at each individual result, for good loan yes, we had a precision of 85%. For recall, we had 97% recall and 91% F1 score. And our model didn't do very well when the value is no. When good loans is no, the precision is 29%. The recall and F1 scores are really low, 7% and 12%. But overall, our random forest model did better than our decision tree classifier model, right? And sometimes our models depend on what we specifically need, whether it's the recall value or F1 score or precision. So depending on what we choose, we can get or use different models, be it random forest classifier or decision tree classifier models. But usually random forest classifier model does better compared to decision tree classifier models. And that's true especially if we are dealing with a larger dataset. For this example, we use a dataset consisting of 1468 rows, about 1500 rows. But the larger our dataset, the better the random forest classifier model does compared to decision tree classifier models. That's another important thing to note. And from the classification report and confusion matrix result, we saw that our random forest classifier model did a bit better than our decision tree model. For confusion matrix, 74 of them were misclassified as false positives or false negatives, whereas 109 of them were misclassified with our decision tree model, right? So those are some things to consider. What we'll do in the next lecture is consider a larger dataset and build a decision tree classifier and random forest models for that bigger dataset and see and evaluate the models. Thank you everyone.